Howdy. Let's take a look at the stuff for the MyAP um, questions. And real quick, so a couple things. This is vector addition. And whenever they give you questions that are on a grid, like it shows here, they're pretty easy because the grid is drawn to scale. So, uh, for instance, this one here, I've drawn a little bit different than the one on the test. This test has questions like this. It has questions where you're having different vectors and different styles. Um, this one is a vector addition that we know is only going to accelerate, down the hill, and so you can do vector addition of ones like these as well. But I'm going to go ahead and kind of show different ways to do this. So on this one, obviously, if we go with the XY axis idea, this one is out of axis, and so this one actually acts that way right there, and that kind of cancels that one right there, right? But this one also acts this way, and if this one was all the way to there, it would cancel out. But this one's a little bit short, the way I have it drawn here, which is different than the one that's on the exam. But then you also have this one here. So in the vertical, they definitely don't cancel out. And so whenever it's in these grids like this, it makes it really easy because instead of doing SOHCAHTOA, you can just eyeball it. Okay, this one right here below, if you say what's the vector addition? Well, the vector addition is going to be somewhere in between this way, but how far exactly? Well, this 2 is going to minus 2 from here. So the total here is going to be 4. Right? The total here between this and this is going to be 4 newtons in the vertical. And then here, this 2 is going to take off this 2. So it's like this 2 takes off this 2. And this 2 takes off this 2 here. And so this is going to be 3 newtons. And the beauty of a 3, 4, 5 triangle is that if you do it like this, and it's a right triangle, then the hypotenuse is going to be the result, and it's going to be a 5. And so that's actually the beauty of a 3, 4, 5 triangle. 3, 4, 5 triangle will always give you a right triangle, and that's just how it is. So, for instance, if I have any triangle, and I say, okay, it goes this way 3, and then it goes this way 4. The beauty of that is that this will be a 5, 3, 4, 5 triangle, and this will be a 90-degree angle. And so that's just one of those beautiful triangles. Okay, the last one I wanted to show you is like if you have, let's say this is like some sort of game where I can put forces on this in order to move the flag. Now, if I put a force this way, it doesn't really matter how I draw it, but maybe I'll say, okay, I'll push it like this with 2 newtons. And then I'll push it like this with 2 newtons. And so obviously that's going to cancel out. You're not going to go anywhere. But if I push it like this and like this with 2 newtons and 2 newtons, obviously these 3 are going to win. It's going to go that direction more. And obviously if I had this exact angles, I could do an exact drawing of how this works. But this will push it to the right by more. Of course, if I went 2 and 2 and 2 against 2, then this would be 6 to the right and 2 to the left. And so it would end up having a result of 4 to the right in that case. This won't be exactly 4 to the right because these are at an angle. But, the question on the exam is kind of asking you which is the greatest amount of total force. Of course, if I do all sorts of things, I could do all 4 of them. I can get rid of that and go all 4. Now, that would be the greatest. They're all 4 going to the right. So, anyways, just to give you a little heads up on how this exam is, I can't remember what other questions there are. Maybe I'll like when we're drawing this, the vector addition of this, right? We want to kind of choose that XY axis. And so if we choose this to be XY axis, oh, this one's not in the XY axis, so I've got to like draw its components, and then I can talk about the components and see whether or not, if it's in dynamic equilibrium, or whether it's in static equilibrium, or whether it's accelerating. The way I have it drawn here, if you just look at it, it really does look like maybe these two cancel, but these two definitely don't cancel. And so for some reason, this thing is going to accelerate that way. I don't know if it was a picture of a hill where this was the hill, that would work, right? I could have something pulling me up the hill. Like, so for instance, I could have like a box, and it could be pulled up the hill with FT. It could be like a skier being pulled up the hill or something like that. So any way you look at it, the Newton's law says that if any of these are bigger than the other, then the rule of vector addition is going to say that the object will accelerate in the direction that the force is winning, as opposed to if I drew this to scale, maybe I would draw this one smaller. So I would draw it like this. And so now these would be like this, and you would have no acceleration at all. It would just be maybe sitting on the hill. So, anyways, vector addition is something that we've been doing. I haven't done a lot of different examples outside of the stuff that we've done. So this quiz gives you a chance to look at some stuff like if you push it at different angles, or if you have a 3-4-5 triangle, or if you have it in this grid situation. So I just wanted to introduce you to some of the things that could possibly be happening. So there you have it, and see if that helps you on the quiz.